Hi, now we're looking at acids, bases and salts here, and let's just take this look and look at the pH scale. This is pH scale, and pH is small p capital H, and it's a way of measuring the strength of an acid or a base, and it runs from 0, which is a strong acid, to 14, which is a strong alkali. So strong acids are very low pHs. An example would this be hydrochloric acid. A weak acid would be something like citric acid, the sort of stuff you'd find in your citric fruits, such as lemons. Neutral would be, an example would be water. A weak alkali would be ammonia. And a strong alkali would be something like sodium hydroxide. Oops. Now notice the colours here. The colours range from red all the way through green, through to purple. This is the colour that a particular indicator called universal indicator would go in these pH environments. Okay, and it's a really useful indicator because it gives you an idea of roughly the strength of the solution in terms of its pH, whether it's acid or alkali. It's not particularly accurate, so you can't use it for much more, but it gives you a good idea of roughly what the pH is. It's not very precise, but it puts you in the right sort of ballpark. So we need to look at acids. What is an acid? Acid, what are they? They donate H+ ions in water. So you need to know 3 examples. One is hydrochloric, which you just discussed. And you need to know its formula is HCl, but in water it releases H+ ions. There we are. The second one is sulfuric acid, which is H2SO4. Now, it's in water, it separates to release 2 lots of H+ ions and an SO4 2- ion. And the last one is nitric acid. Nitric acid is HNO3. It separates in water to release H+ plus NO3- ions. So you can see they all release H+ ions in water. Yes, they have characteristics that mean that they have a pH of less than 7, and they turn universal indicator orange to red, but that's not what defines them. What defines them is the fact that they donate H+ ions in water, and we'll look at that later on. Now, when you do acids, you often look at at bases. Okay, so what is a base? A base is a metal, oxide, or hydroxide. And what they will do is they will accept H+ ions. So acids will donate H+ ions, and bases will accept H+ ions. Okay, so an example would be, e.g., hydroxide ions, and more specifically sodium oxide or sodium hydroxide. Okay, if you add H+ ions, you get water. Okay, likewise, if you had H+ ions here, you get sodium ions, yes, but you also get water. Okay, and this process by acid plus base goes to salt plus water. This is called neutralization. Oops, I should probably do that in green. And we can summarize that in an equation whereby we have H plus ions from the acid plus OH minus ions from alkali to give H2O, which is water. Okay, that's a really important equation where we just look at the ions involved and then we can say what is the reaction that's occurring here. Now, one of the terms I've used here is alkali. Now, what's the difference between a base and an alkali? Okay, so if we look at it, an alkali is a base that dissolves in water and it releases OH minus or hydroxide ions. So there you go, that's where we saw it. Okay, so that's what an alkali is. An alkali is a base that dissolves in water and it releases or donates OH minus ions. Lots of people get very, very confused by acids and bases and alkalis because they're sometimes used interchangeably, but they are slightly different. So bases, where are we now? We are at salts. Okay, salts are compounds formed when acids react and have their H plus ions replaced. And I'm thinking for, so if we do HCl is our acid and we react it with sodium hydroxide, we end up with the salt sodium chloride plus water. Let's move this out of the way. Okay, so this is our salt. And what's happened is the H plus there has been replaced by sodium. Okay, so hydrochloric acid forms chloride salts. Sulfuric acid I lost myself there. Forms sulfate salts. And nitric acid forms nitrate salts. Okay, so let's give you an example of a chloride salt. So that would be e.g. sodium chloride, or e.g. sodium sulfate, e.g. sodium nitrate. Okay, so those are the three examples of salts that you need to know. Let's just clear that up and put that there. Right, reactions of acids. This definitely needs to be worked on because there are 4 reactions we need to know. Acid plus metal. Oops, why have I put the E on then? Metal goes to salt plus hydrogen. So we've got hydrochloric acid plus a reactive metal, say sodium. We'd never do that, it's way too reactive. Sodium goes to sodium chloride, which is your salt, plus hydrogen. So that'd be HCl plus Na goes to NaCl plus hydrogen is H2, and so therefore we're going to have to balance that, put a 2 there, put a 2 there, and put a 2 there. So there's the first one we need to learn. The second one is going to be acid plus, let's change that, metal oxide forms salt plus water. So let's put sulfuric acid plus, let's say, magnesium oxide So it's the magnesium reacting with the sulfuric acid. The sulfuric acid forms a sulfate, so it's magnesium sulfate plus water. Okay, so let's put that down in a symbol equation. That's H2SO4 is sulfuric acid. Magnesium oxide is MgO, forming magnesium sulfate, which is MgSO4 plus H2O. Okay. Right, next one. We're going to be looking at acid plus metal. Keep doing that. Why am I doing that? I keep writing melt. Metal hydroxide. Now we've looked at this one, and that forms a salt plus water. So if we put nitric acid plus potassium hydroxide, we get potassium, and remember nitric acid forms a nitrate salt, so that's going to be potassium nitrate plus water. If we give that an example in terms of a calculation, is HNO3 plus KOH, potassium hydroxide, goes to KNO3 plus H2O. So it's the same product, salt plus water, as the previous one, but the ratios are often different. So, and the last one is going to be acid plus metal carbonate reacts to form a salt plus water plus carbon dioxide gas. So let's have a look at this one. Let's do sulfuric acid plus magnesium carbonate reacts to form. Now the salt is going to be a sulfate salt, and the metal bit from this magnesium carbonate, so it's going to be magnesium sulfate plus water plus carbon dioxide. So that's going to be H2SO4 plus magnesium carbonate is MgCO3. That's going to form MgSO4 plus H2O plus CO2. Now you will be expected to balance some of the equations, but more importantly you need to know what the products are, whether it's salt and hydrogen, salt and water, salt and water, salt and water and carbon dioxide. So that's the hardest thing, and then you'll need to be able to know what the name of the salt is, or if you know what the name of the salt is, what the acid was that made it up. So that's a classic sort of question exercise. So these are the 4 reactions. So there's 1, here's 2, here's 3, and here's 4. Those have to be learned. Okay, so going back, we worked out what an acid was. Yeah, what are they? What a base was and an alkali. We talked about a neutralization reaction. Then we talked about salts, what they were, and then the reactions of acids to form salts. Now, lastly, we need to look at indicators. Now, we know of one indicator already. We know of universal indicator, and that's really good at telling us the pH. Okay, but we need to know 3 other indicators. We need to know litmus. We need to know phenol phthalate. That's a weird name. PHTH phthalate. And we need to know methyl orange. We need to know what colour they're going to be in acid and in alkali. So in low pH and in high pH. Litmus in acid is very, very straightforward. It's red. Okay. In alkali, it's blue. Phenolphthalein is an odd one. In acid, it's colourless. Not just clear, but colourless. In alkali, it's an odd one because it's a pink colour. It's the only one that's pink that you'll come across that's in an alkali. And lastly, methyl orange. In acid, it's a red colour, but in alkali, it's yellow. Okay, so we've got red, we've got colourless, we've got red, we've got yellow, we've got pink, and lastly we've got blue. I don't have a blue here, that's odd. Okay, didn't think that through, did I? Okay, so things we need to know. pH scale for acids and alkalis and examples. What is an acid? The fact that they donate H+ ions in water, and 3 acids. Okay, hydrochloric, sulfuric and nitric acid and their formulae. What a base is? Something that accepts H+ ions. And what an alkali is from a base, which is a soluble base, which releases, where are we? Alkalis release OH- ions in water. What you get when an acid and an alkali react, it's an equation like that, where the H+ ion, sometimes known as a proton, you might see, is reacted with a hydroxide ion to form water, and that's called neutralization. That's what we've got here, neutralization. Okay, and then we were looking at salts. What are salts? Salts are compounds formed when acids react and have their H plus ions replaced by a metal ion or ammonia. Okay, and an example we had was sodium chloride made from hydrochloric acid. You need to know that chloride salts are made from hydrochloric acid, sulfate salts are made from sulfuric acid, nitrate salts are made from nitric acid. Then you need to know the four main reactions of acids. Acid plus metal goes to salt plus hydrogen. Acid plus metal oxide goes to salt plus water. Acid plus metal hydroxide goes to salt plus water as well. And lastly, acid plus metal carbonate goes to salt plus water plus carbon dioxide. And then lastly, you needed to know what an indicator was. An indicator is something that changes colour when in acid or alkali. You know what universal indicator is useful for, but we need to know three other ones: lipness, phenolphthalein, and methyl orange. They're much more accurate than the universal indicator. And you need to know that the fact that lipness is red in acid and blue in alkali, phenolphthalein is colourless in acid and pink in alkali, and methyl orange is red in acid and yellow in alkali. Okay, we will need to look at solubility rules for salts and salt preparation next time.